of Invnorm Normalcdf. Okay. So I'm not going to actually solve. We're just interested in what do we have to type into our our TI-84. Okay. So calculate the probability or percentage of bags weighing between this and this. So when I give you a low and an upper, these ones are quite straightforward. You just have to remember, what are we using here? We're using Normalcdf. Why? Because we're finding percentage under the curve, right? So this is 232, 273, and then mean and standard deviation, right? And you multiply that by 100 to get your answer. I guess I could give you the answer, why not? Probably checked it already, 99.98%. So if you think about it, okay, I'm going to use 232 is somewhere here, right? And 273 is somewhere here. So we're talking almost end to end, right? There's very little that isn't under the curve, like on the tails here. So that's why that makes sense. Percentage of bags heavier than 257. 257 is right about there. We want everything to the right of it because it says heavier. Okay, so then you have to be careful. Normalcdf. And 257 is your lowest. And here I just put in a really big number. Right? Tell me when to stop. Anyways. And then just 250 and 5. Yeah, it's kind of annoying that it's not like, tell me a number and I just want to use it every time. Just a big number. Okay? So if this is millions that we're talking about, talking salaries like hockey players, everything is millions, then you better go more than 6 zeros, right? You got to go 100 million or something really big that makes sure that you encompass everything. So basically what you want to tell the calculator is from here to infinity. But we don't have the infinity button. Like if we typed in infinity, the calculator would just keep on going. It would crash eventually, right? So you got to give it a limit, but not infinity, of course. Morning. I used to use a different something else here. I might introduce that later on. Some of you might appreciate that, but later. Okay, this works every time. A percentage of bags weighing less. So there's the key word, weighing less than 243.5. Where's 243.5? It's right about there. So you want, imagine a line there. You want everything to the left of it because it says weighing less. So we got to go Normalcdf and a really small number. Tell me when to stop. Okay, anyways. All right. And this is 243.5, 250, and 5. Okay, times 100, and you get that answer. You should get 9.68%. I'll tell you this, if for whatever reason you're off by 0.01, because I picked a really small number and you picked maybe a number that isn't quite as small as mine, you will lose 0 marks, okay? Because I will just look at your entries, and if they make sense, you get the marks, okay? If it's not a low number, then you're obviously not going to get the marks. This one is the one I already alluded to yesterday. It says we want to get rid of all bags, right? Dispose, right? Get rid of anything weighing less than 239. So 239 is here. You got to be comfortable making a quick bell curve, okay? And anything weighing more than 262. So we're trying to get rid of the ends. These are the good potato chip bags, right? Anything in between is good. This is bad, right? Dispose, dispose. So you have 2 options here. My preferred method is 1 minus Normalcdf 239 to 262. 255. Why? 1 is the total area under the curve, 100%. I'm going to subtract the good ones, right? Because if I go from 239 to 262, this represents the probability of a bag being good, right? Like it passing. So if you do the math for this part, you get 0.9778, and it keeps going. And in total, you get 0.0221, and that keeps going as well. At this point, I multiply that by 100, you get 2.21%. Okay. This is one way of doing it. My preferred method, or I should have left more space, or you go normal CDF. So if I want to figure out this part, I'm going to go negative, a really small number, to 239, 255, right? I figure out what that is. Then I do another normal CDF where I figure out all the bags that are here. So that would be from 262 all the way to infinity, positive, that is. Okay, 255. You figure that out. I think my key doesn't have, oh yeah, I do have it. 0.0139, and this keeps going on my calculator, and this part gives you 0.0081 and something, okay? And if you add those up, if you add these two up, you still get 0.0221, right? If you multiply that by 100, you still get 2.21%. So it's up to you how you want to do them. I honestly don't care. Just make sure you understand what you need to do. Okay. This is called indirect reasoning, where you go for what is not being asked for, and you subtract it from the total to get your answer. I'd say this is a bit more efficient in my opinion, but you're talking maybe half a minute longer to do it this way, right? Not a whole lot of change there. Then 34 on the back side, this is I, right? And then double I, if we go to 35, we're going to use this answer to answer this question right here. Okay? If the company produces 5,400 bags per day, how many bags would be removed from the production line? And so 2.21% of bags are removed, okay? We figured it out on the previous page. So number of bags, if you want number of bags, you turn that into a decimal, okay, and you multiply it by the number of bags. And you get 119.34, and at this point, because it's asking for number of bags, you will say, right, approximately 119 or 120 bags. Okay, so that is an answer there. We're good so far? Okay. What percentage of bags have a weight with a z-score of between -0.6 and 1.34? What is this? Remember, when you made your bell curve on the previous page, you had the actual weights here, but then underneath you had z-scores, right? So every weight has a z-score that goes with it, guys. And I'll tell you why later, okay? It's a way to standardize things. Z-scores standardize everything. So we can actually just, it says percentage of bags, correct? So we can actually use normal CDF. And you can actually use these numbers. Like it gives you a low and a high, right? What is my mean and standard deviation when we're talking z-scores? 0 and 1. Okay? 0 and 1. So you gotta make sure you understand if it's z-score, I'm gonna make a little bubble here, right? You should be thinking mean is 0 Now I kind of butchered it there. Mean is 0, standard deviation is 1. As soon as you see the word z-score, okay? And that's where I got this from. Okay, so you immediately, I'll tell you another secret. Now you're ready for the secret. You know when teachers told you can't take the square root of a negative number? They lied to you. If you go into calculus, there's a way of doing it. It's just like you're not ready for it yet. Yeah, that's all we're saying. If you were to not enter, like if you just enter these two values, the calculator would automatically assume that the mean is 0 and the standard deviation is 1. So if you leave this blank, if you just feed Normalcdf these two numbers, that's it. It will automatically assume this is 0 and that's 1. I would still prefer you just go 0, 1, just to not mix it up with a different question, right? If you do this, you get 63.56%. Okay, if you do this right. Now it says calculate the actual weights that correspond to each z-score above. So each one of them has an actual weight, okay, actual weight. So you just use this formula. How does it go again? Something like this, I think. Okay, so just use this formula that I gave you. And so for the standard deviation is always 5. The z-score for the first one is negative 0.6 plus whatever the average is. And this gives you negative 3 plus 250, which is 247 grams, right? A bag with a z-score of negative 0.6 has a 247 gram actual weight. Okay, and then next you do that the same thing with the other z-score here. Standard deviation is 5, z-score is 1.34 plus the mean. And you get 6.7 here plus 250, and that gives you 256.7 grams. Okay, so you could run Normalcdf again if you wanted to compare this answer to using z-scores. If you use 256.7, and then you have to use 250 and 5 because you're using the actual scores, you would get 63.56 as well. Okay. Very close at least. And now is inverse norm time. Okay. The company would like to know the weight, right? You want to know not percentage, not probability. You want to know the actual weight that would place 65% of the bags produced below this weight. Okay. Can I just give you a heads up? I might ask you this. 65% of bags, if you want to rewrite it somewhere in here, weigh less than grams. I might just state that like that. That's another indicator. It's like, oh, I have to use inverse norm. So you have to read carefully. Okay, make a little bell curve for yourselves. If 65%, this is always less, right? Shorter, less, right? And this would be more. In this case, 65% way less. Where do I make my line? Always think if I made the line right here, I would have 50 less, right? So I need to be further over to this side. And this question is actually giving you the percentage of bags that are to the left of this value you're trying to find. This is already doing that, right? So we got to go inverse norm. And you go 0.65. And the mean and standard deviation, of course. In this case, you get 251.93, and that is grams. Okay, whatever the x values are on your bell curve, that's what the units are for this for this answer right here. The company would like to know at what weight would 6% of the bags produced, there's a typo, right? Sorry, be heavier than it. I'm gonna feed this to Google Notes LM. So can you fix all the typos, please? Sure. In this case, where is the line? You should have it somewhere on this extreme here, because at this weight that you're about to find, you have 6% of bags weighing more than it, right? So it makes sense that the line would be higher up. If this is 6, then this is 94. You take that away from 100%. This is the one we're interested in. That is usually worth a mark if you have to find the left side. Then it's inverse norm. Morning. 0.94 to 55. If you do that, I'll just give you the answer. That's 257.77 grams. Okay? And that last one, I don't know if you were able to do that. Determine the z-score of a bag that is heavier than 55% of the bags produced. Okay, let's pretend you have this formula on your study sheet, right? And you want to use this. Can you use this formula? Let's see, do we know the mean? Yes. Do we know the standard deviation? Yes. Do we know the actual score we're talking about? We don't. So you can't use this one. Can't use this one, because this one is unknown here. Okay, so let's try it. If I give you percentage, chances are you might want to try this one, inverse norm. But the key here is to figure out, is the percentage to the left or to the right of the value you're interested in. A bag that is heavier than 55% of bags. This would be, this is the middle 50, 55 would be right about there. So it's asking for this z-score, right? And this z-score places you heavier than 55% of the bags. So in this case, I give you the left-hand side already. Is my key the other way around? I have a feeling that. Or is this not on my key? Well, if my key says 45, it's supposed to be 0.55. So if I got you all mixed up there, I'm gonna check the key. Why am I going 0, 1? Because it's asking for z-score, okay? So that's why I go 0, 1. So I don't go 255, okay? I go 0, 1. And that's another way of getting your z-score. So you're supposed to get, let me just get this here. Why am I not seeing it? 0.13. Okay, 0.13 is the z-score. There's another way of doing this. Maybe I will just show you. If you went inverse norm, maybe write this down. It's good to see the connections. Inverse norm, and you went 0.55, and then you went 255 instead of 0, 1. Then you're actually finding the actual weight where 55% of bags are less than you, or you're heavier than 55%. Then you get 250.63 grams. Once you get that, you can actually use this formula to figure out your z-score. So it's 250.63 minus 250 divided by standard deviation. You still get 0.13. Okay? So regardless of how you do it, you should arrive to the same conclusion. Okay. Fun stuff, eh? Yeah, some of you are loving it, some of you are hating it. I understand that. But trust me, you will hear of z-score, standard deviation, normal distribution. You will hear about that somewhere. You listen to someone talk down the road. Obviously, you're going to be older, right? Because right now you're probably not listening to those podcasts or whatever that talk about normal distribution, but it will come back, I promise you, at some point, and you will have an idea of what they're talking about. Okay. What about this one? Determine the z-score of a bag that is lighter than 31% of the bags produced. Okay. Of a bag that is lighter than 31%. So in this case, you want this here because this bag is lighter than 31% of the bags produced. Okay, that's what we want. Okay, so this is 69%, which makes this inverse norm 0.6901. Why 0.1? Because I want the z-score. Okay, and that gets you 0.5. That's my z-score there. I'm going to skip this one because you just use your formula for this one. Just write this in there if you haven't done it. And the answer is, I put it in brackets, it's 1.85. In case you want to try that on your own time. Now, this is the one I want to talk about now. Okay, this is my lesson for you on this one. If you didn't know how to do this one, I don't even know if it was on the key because I did put new on it because it is a newer concept that I've been starting to cover. So make sure you write this down and have some highlighters here. It's just an extension of what you've learned. Okay. COVID symptoms last 7 days on average with a standard deviation of 0.5 days. If the duration of the symptoms is normally distributed, determine the middle 80% of cases last between this many days and that many days. Okay. Okay, the emphasis, the first part is this, the middle 80% of cases. You literally, we're going to try to slice this up and say from here to here, this is like the middle sort of, that's 80%. Okay, this you start off with that. That's 80%. And we want to know the number of cases here, right? And the number of cases here, right? 80% of cases last between this many days and that many days. We're going to try to find out. Okay? Okay, follow me here. I'm going to use a red pen for this one. Let's fill in what percentages that we could find out. If 80% is already taken, what are both of these going to be? 10 and 10, right? 10 and 10. So I'm going to go 100 minus 80 divided by 2. So that's 20 divided by 2, which is 10%. So we use the symmetry of this curve. So that means that this is 10% and that is 10%. So I think that one you can probably wrap your head around. So if this had been the middle 50%, then there's 50 yet to be split out. So this would be 25, 25, right? So it depends. How could we find out this value right here? Inverse norm. And what is to the left of this value right here? 10%. And what's my mean? 7 days, right? It's right here. The mean is right here. X. Standard deviation is right there. So just type in that. So I'm going to go off of this and just say that's what I'm doing here. Let's figure out the number of days there. And for this limit here, I will do another inverse norm. Just pay attention to this part. What's the percentage to the left of this value? 90, right? Not just 80, because you want everything to the left. So you got to go 80 plus 10, so that's 90%. Okay, 80 plus 10, that's 90%. So this should be 0.9, 7, 0.5. And we'll figure this out as well. I'm going to use two different colors here so you can see. So the orange here, that's that. Orange, green, sorry. Colorblind. And then this part right here is the 90%. So that's why we have that. If you do the first one, you get 6.36 days. And this one is 7.64 days. Can you have decimals of a day? You might disagree, but yes, you can. Time can be broken down even smaller units, right? You can do days, hours, minutes, seconds. You can actually break time down, right? So it's okay to have decimals. If I ask you how old will a person be, right, and you figure out the years, you got to add it to the age and then round the number, but in this case, no. So you can just leave it like this, or you can type this, fill this in. Between 6.36 days and 7.64 days, that's like your middle 80% of cases. Most of our cases, that is, last between this many days and that many days. Okay. So this is kind of like a variation of what you've been seeing. Okay, and if you use symmetry, okay, we use the symmetry of the. Maybe I'll make a note there. We use symmetry, okay, to answer these types of questions. All right. A lot of stuff, right? I'm going to stop there.